Hi, hello my dear students. Welcome back to our class. Yesterday we are discussing about the human eye and the colorful world. In this lesson, yesterday we are learn about the human eye and cataract and power of accommodation and the defects of human eye and its corrections also. I hope that all of you understand the topic yesterday. Now, today we are discussing about very important topics are the refraction of light through prism and dispersion of light, rainbow formation, atmospheric refraction, scattering of light. Now we have to um, learn about these topics today. Now let us start the lesson. Introduction. Good morning students. Welcome back to our class. In the previous lesson, we learned about the human eye, power of accommodation, defects of vision, and um, defects of vision and eye donation also. Today, we are going to learn some of the most beautiful phenomenon in nature. Have you ever wondered why does a rainbow appears after rain? Why do stars twinkle? Why is the sky blue? Why does the sun look red during sunrise and sunset? Today we shall find the scientific answers. Let's begin. The first topic is refraction of light through prism. Students, you already know that when light passes through a glass slab, it bends due to refraction. But in a glass slab, the two faces are parallel. Therefore, the emergent ray is parallel to the incident ray. Okay. Now observe this triangular glass prism. Now we have to observe the glass prism today. Its two refracting surfaces are inclined to each other. Hence, light bends continuously when passing through the prism. As a result, the emergent ray is not parallel to the incident ray. Okay? Instead, it deviates. Here we have to show this activity 10.1. Here we have to given. Let us perform a simple activity. Fix a white sheet on drawing board. Place a triangular prism. Trace its outline. Fix two points. Sorry. Fix two pins in front of the prism. Observe the images through the opposite face. Fix another two pins in such a way that all four pins appears in one straight line. Remove the prism. Join the points. Draw normals. And mark angle of incident, angle of refraction, angle of incident I, angle of refraction R, angle of emergence E. Okay. Now we have to show this figure. Now what we observe? The emergent ray deviates towards the base of the prism. The angle between the original direction and emergent ray is called the angle of deviation. Okay, once again I have to repeat. The angle between the original direction and emergent ray is called the angle of deviation. Now entering the from air into glass. When light enters from air into glass, it bends towards the normal inside the prism. Light travels inside the prism and bends at the second surface. And third one is coming out from the glass into air. When light comes out from glass into air, it bends away from the normal. Okay. Here we have to observe because of the triangular shape the emergent ray bends towards the base of the prism. The angle between the original direction and emergent ray is called the angle of deviation. Okay, this is the concept of refraction of light through prism. Now, dispersion of light, dispersion of white light. Okay, now we have to see here. Now observe another interesting experiment. Allow a narrow beam of sunlight to pass through a glass prism. Why do we observe instead of white light? We get seven beautiful colors. This phenomena is called dispersion of light. Okay, what are the colors are there? That is called VIBGR. In VIBGR, V indicates violet, I indicates indigo, B indicates blue, G indicates green, Y indicates yellow, O indicates orange, and R indicates red. Okay, so we have to remember in shortcut it is called VIBGR. Why does dispersion occur? Why? Is it not what happens? Each color has a different wavelength. Different colors bend by different amounts of inside the prism. Violet bends the most and red bends the least. Hence, white light splits into seven colors between violet and red. Okay. Here we have to show the wavelength and bending also. Here shorter wavelength is indigo and longer wavelength have is red. Okay. Now, now white light through one prism. We have to see this. We have to the white light goes to prism and it comes out into seven colors. Okay, white light splits into seven colors. They are called violet, indigo, blue, green, yellow, orange, and red. The seven colors are obtained. Here we have to prove this one using the experiment, Newton's experiment. Newton takes a white light into through the prism, and it can be divided into seven colors. And through an inverted prism, the seven colors go to in the prism, and it can be comes out in white color. So colors come recombine when passed through an inverted prism. Okay, then white light again comes out. So all the colors combine together and form white light again. This is called Newton experiment to prove the dispersion of light. Now we have to how to form the rainbow. Have you ever seen a rainbow after rain? A rainbow is actually a natural spectrum. Tiny water droplets present in the atmosphere acts like small prisms in atmosphere. Okay, so each inside the each droplet, the sunlight undergoes. First one is sunlight comes to the water droplet, and in that droplet, the refraction is happen. So sunlight enters the water droplets and bends, and white light splits into seven colors inside the droplet. The light reflects internally from the back surface. Then the light comes out of the droplet and bends again. Okay. Here we have to see the how to form the rainbow. Therefore, we see a beautiful rainbow opposite to the sun. Okay. Here, what we learn in this class, white light is made up of seven colors. Different colors bend by different amounts. A rainbow is formed due to refraction, dispersion, internal reflection, and refraction again in the water droplets. Then it comes out the seven colors forming in outside. So this is called rainbow. Nature uses the principles of light to create beautiful phenomena. Okay, this is the the about of this is the about of dispersion of light. Now we have to learn atmospheric refraction. It is also very important topic to understand in our nature. What is atmospheric refraction? What is the atmospheric refraction? Earth's atmosphere is made of many layers of air. Different layers have different densities. Therefore, light bends continuously while traveling through the atmosphere. This is called atmospheric refraction. We have to see here low density to high density layers in the earth. Now we have to learning about twinkling of stars. How you notice that stars twinkle? Stars are very far away. They appear as point sources. Their light continuously bends due to atmospheric refraction, hence their apparent position keeps changing. Sometimes they appear brighter, sometimes dimmer. Therefore, stars twinkling. Due to refraction, the light from the star reaches the observer along a curved path. So the star seems to be in a different position. Here we have to see in this picture how to stars twinkle. Okay. Next, why don't planets twinkle? Planets are much nearer to Earth. They appear as a extended sources of light. So the small changes average out, hence planets do not twinkle. Light from different parts of the planet bends differently, but these variations are average out. So the planet appears steady and does not twinkle. Okay. Now, here we have to learn about advanced sunrise and delayed sunset. Students, the sun becomes visibly about 2 minutes before actual sunrise. Similarly, it remains visible for 2 minutes after actual sunset. This happens because atmospheric refraction bends sunlight towards our eyes. Therefore, we see the sun even when it is actually below the horizon. This is called advanced sunrise and delayed sunset. Here we have to see in this picture. Advanced sunrise about 2 minutes early. Here, actual position is below horizon, but apparent position of sun is above the above the actual. So the effect refracted sunlight comes, and we have to see it in before 2 minutes early. We see the sun when it is actually below the horizon due to refraction of sunlight in the Earth's atmosphere. Here, time difference is about 2 minutes. And delayed sunset. Here is also actual position of sun is below horizon, and we have to see the apparent position of the sun is below the actual position of sun. So here is also delayed sunset is about 2 minutes late. Okay, we see the sun even after it is actually below the horizon due to reflection of sunlight in the Earth's atmosphere. Key points: light bends while passing through different layers of the atmosphere. Atmospheric refraction causes many beautiful natural phenomena. These include twinkling of stars, advanced sunrise, and delayed sunset. Okay, atmospheric refraction shows us how light behaves in our atmosphere and helps explain many wonderful phenomena in nature. Okay, this is about the atmospheric refraction. Now we have to learn about scattering of light. Scattering of light. What is scattering of light? Now let us understand another beautiful phenomena when sunlight strikes tiny particles of dust smoke, or water droplets, the light spreads in different directions. This is called scattering of light. Here we have to see the picture. The light is scattered. For example of scattering of light is fog, mist, smoke. Okay. Now we have to learn about examples of scattering of light in our daily life. First one is Tyndall effect. Students, suppose sunlight enters a dusty room through a small window. Can you see the path of light? Yes. Why? Because dust particles scattered light. This phenomena is called Tyndall effect. It can also observing the fog, mist, and smoke also. Okay. The second example is why is the sky blue? If you have think anyone how the sky is blue, why? What happens? The uh, sometimes what happens? The sky is black. All of you, are you all thinking about this? Now we have to know the answer. Sunlight contains seven colors. We have to know. Oh, blue light has a shorter wavelength. It gets scattered much more than red light. The scattered blue light reaches our eyes from all directions. So therefore sky appears blue color. Okay. This is the cause of sky appears blue. And second one is third one is why is the sun red during sunrise and sunset? During the sunset and sunrise, sunlight travels a much longer distance through the atmosphere. Most of the blue light gets scattered away. Only the red light reaches our eyes. Therefore, sun appears reddish. These are the reasons of during the sunrise and sunset, the sun appears red. Next one, why are danger signals red? Red lights has the longest wavelength. It is scattered the least in the atmosphere, so it can be seen from a long distance. So we have to use the signals, danger signals in red color. Here we have to given how much the color of light is scattering in the atmosphere. Here violet is the most scattered and red is the least scattered. So these are all the difference between scattering in the atmosphere. Here, if there is no atmosphere, the sky would appear black. The same reason actually why danger signals are red, they scattered at the least and remain visible from farther away. Thus, scattered of light is the atmosphere gives rise to many beautiful phenomena in nature. Okay, here we have to give some more examples and how to learn in this topic. Scattering of light occurs when light strikes tiny particles. Tyndall effect makes the path of light visible. Sky appears blue because blue light scatters the most, and sun appears red during the excuse me, some disturbance are here. Now we have to clear this. What we learn in this lesson, once again we have to repeat. Scattering of light occurs when light strikes tiny particles. Tyndall effect makes the path of the light visible. Sky appears blue because blue light scatters the most. Sun appears red during sunrise and sunset because red light scatters the least. Red colors of danger signals is due to least scattering. These are the key points to learn this topic scattering of light. Now, what we learn in this lesson today, we have to revision quick. Here we have to discussing the topics are refraction of light through the prism and the formation of um, how to form the rainbow, formation of rainbow, angle of deviation, and dispersion of light, Whipsier colors, Newton's prism experiment, rainbow formation, atmospheric refraction, twinkling of stars, advanced sunrise and sunset, delayed sunset, and scattering of light. Excuse me. And Tyndall effect. Why is the sky blue? And why is the sun red during sunrise and sunset? These are all the main key points to learn today class. Okay. Now, students, nature is full of wonderful optical phenomena. By understanding refraction, dispersion, atmospheric refraction, and scattering, we can explain rainbows, twinkling stars, blue skies, and red sunrise sunsets using the principles of science. Okay, I hope that all of you understand this topic, the human and colorful world. Thank you, students. Have a wonderful day and keep exploring the colorful world of science. We have to meet again in our next class. Thank you. Thank you so much.